This is Kevin with Let Me Tech You, and today I'm going to be going over single area OSPF. And with that, I'm going to be going through our blog article here. Let me pull it up. So, in this article, this design, it's changed a little bit. Let me clear some of this stuff off my other screen. So, it's changed a little bit from my current design here, and nothing in particular. I just kind of used some different devices in my home lab that kind of didn't play too well with a migration I had did. So now like those older images weren't working. So I just wanted to update it a little bit. And here I'm just using some layer 3 switches that's connected into the switch that basically has another router up here that, was just provisioned to pretty much act like, the internet or whatever. But I just kind of wanted to simplify a little bit. It may not look simplified, but basically I just made this as just going to act as a switch. And then these routers here are going to be what's going to be running the OSPF. Now this is single area, just area 0 OSPF. So single area OSPF is great for when you're basically in a small network, just a couple routers. Everything is kind of connected, pretty simple. So you don't have to really worry about like large routing tables or large link state database updates, things like that. And this, basically kind of enables you to move away from having to do static routes and things like that to provision access across your network. Because as you start to grow, you will run into administrative overhead having to maintain those routes as things change. So I'm going to go through setting some of this up here. Now, basically, a lot of this was previously set up. So what I'm going to have to do is configure some of the information that's in our network diagram here using like some of these. So basically like these IP addresses will just be a little different. Again, you can still kind of follow along. These interfaces are also going to be different, but the overall architecture premise behind this configuration will be the same. So let me bring these up here. And as you can see, I have my networks kind of defined. And that was another thing too. I wanted to kind of simplify the IP address scheme too. So, I have like 24, 25, and I'm jumping to like 8, 9. Now I'm basically just going 8, 9, 10, 11, 12, just to make it simple. So I'm going to go ahead and provision some IP addresses over here on these PCs. 10 dot, I believe what I use. 10.10, okay. And I'm just going to do 5 and then /24. Default gateway will be 10.10.8.1. And I might be able to copy paste this. All right, so if I go into the other PC, it's not going to let me. Okay, so 10, 10, 8, 10. 10.8.10. Then 10.10.8.1. Go over here, IP. All right, so I got that configured, and just gonna do that real quick for these other ones. So this is gonna be on the 10.10.12 network. 10.10.12.5/24. And then 10.10.12.10. 10.10.12.10/24. And then our default gateway. All right, so now that those are set up, basically These switches are just going to act as switches. Nothing. I'm not going to do any different VLANs or anything like that. Not going to change the host name, but basically, just want to make sure that these ports, port 1.1 and 1.0 is up. Show IP interface brief. So those are up. Now, what I want to do is assign my default gateway, which is that 10.10.8.1 to the gigabit 0/0 interface on. This is router 2. Give us a second here. So, okay. T, host name, router 2, and then (0/0). Let's make sure. So, okay, 0/0. And then IP address 10.10.8.1. Oop. 255. All right, so we got it configured there. Now, from this particular PC, I should be able to ping 10.10.8.1. Let's try that here. Host, let's see what's going on here. So let's go back to let's do a show IP here, 10.10.8.5, 10.10.8.1. Let's see. Here, gigabit 0/0. Let's make sure these are all up. No problems there. And let's make sure all of our interface on our routers is show. Let's exit out. Show IP interface brief. Okay, so they're down. So can't type today. So interface gigabit 0/0. Let's do a no shut. That should come up there. There we go. So now let's bring everything up because we're going to need those other ones. So interface range 0/0 to the third interface. Ooh. No shut on all those. So we brought all those up. And we can confirm that. Show IP interface brief. So all of those are up. Now, if we go back to PC1 and try to ping that again, it should be up. So now we're getting connection to our router there. So now we have full connectivity to both sides. Well, on this particular network. So let's test this one as well. Lose the first ping and get the other ones. Okay. So now we've got that working. Basically, just going to run through real quick and configure these other sides. So let's do, so 10.9.1 would be, and actually, let's try and see if we can put these on both sides here. So where's my topology? Okay, so interface gigabit 0/1, IP address 10.10.9.1. And then /2, IP address 10.10, 10.1 there. And let's go over to router 3. Let's bring that over here. Let's do the same thing. Let's actually get these other ones going real quick. This over to here. All right, so these are using Ethernet. Different router I had used in my previous lab. I'm going to switch that out probably in another video for one of these gigabit Ethernet interfaces, but not going to worry about that right now here. So let's T interface Ethernet 1/2 IP address 10.10.10.2, and then 1/0. Let's make that 11.2. All right, and then router 3 here. Change the host name on the other one, but it's okay. So now let's get this one going. That's interface range gigabit 0/0. So 3. And no shut. And bit 0/0. So this is going to be IP address interface 10.10.12. And then for gigabit 0/1, it's going to be 10.10.9.3. And then for 0/2, it's going to be 11.3. Okay, so we got all those configured. All our interfaces configured. All our interfaces are up. Show IP interface. So all those are up. Now, if I take one of these, let's just try to ping 10.12. Or no, 10.10.12.1. Should be able to get the ping going. Okay. Now, so we have that all that configured. Now, in a network, you may need to, connect to PCs, end users, anything as far as servers on another part of your network. So this might be on one side, might have your data center, or this side could have other services like your phone system, things like that. But to get to those other sides, you would need to have these routers know the path it wants to take. And sometimes with that, you can use what's called your static routes. But the problem with that is, say if that route was to go down, the static route won't be able to automatically adjust to the next available path. And that's where dynamic routing protocols such as OSPF comes in. So what we're going to do is, if I was to take this particular PC and try to ping 10.10.8.5, which is a PC on that side, you shouldn't be able to. So if I go ping 10.10.8.5, it's not going to be able to get to it. And because of that, if we look in our router for router 3 here, we're already on it. If you do a show IP route to look at the routing table, it doesn't know how to get to 10. The 10.10.8 network. You don't see that anywhere in there. So what you need to do is then, what you do from our article here is enable single area OSPF. So to do that, we're going to go in and configure this on all of our routers here. Now, pull this up. So we're going to start on router 2 from our design, and basically put this configuration in there. So basically we go here and go IP. Well, this is already a routing, so you don't need that first one. If this is like a layer 3 switch or something that doesn't have routing enabled, you can basically do IP routing, turn it on, and then IP. You could do router OSPF. Now this is the process ID. Now typically you want to keep this. Doesn't have to match, but kind of make it to where kind of makes it easier for troubleshooting purposes if you just don't kind of just do any particular IP address that's out there. Now, another thing you want to do is you're going to want a router ID. The router ID helps identify your routers in the OSPF process. So what you'll want to do is we're going to make a loopback address. Interface loopback 0 and IP address 2.2.2.2. All right, and then that comes up, and then so let's do router OSPF 1, 2, 3. Let's do OSPF 2, and that gets you into router OSPF configuration mode. And now these network commands, what these are is it's identifying the interfaces that's going to be basically processing your OSPF. This isn't necessarily the networks that you're actually routing for, just the interfaces in which those particular networks are coming from. So as you can see here, it has 3. So we want to process anything that's coming off of this interface here, this one here, and this one here. And this is how that entire process takes place in terms of identifying how to take the best route. So if I go back in here and just do a network, and we could actually do 10.10. And there's other ways you can do it. You can either do it on the interface as well. It's best to kind of do it from the router configuration or the OSPF configuration mode. That way it's all in one place when you need to go and make changes. So 10.10.8.1. We could actually, let's see. So it's actually, 0.0.0.0. So that's just saying anything that resides on this network there. Well, not network, but basically interface, but that network. And then you're just going to do area 0. So this means all of our information will reside in this one single area. And then we want to do the same thing for 9.1 and then 10.1. All right, and then we want to go ahead. Let's do router 3, interface loopback. Let's do 3.3 or loopback 0. IP address 3.3.3.3. 255. IP address. Let's go. Oh, okay. Shut, and then router OSPF. Now these don't have to match, these router OSPF process IDs, but you can kind of, make them what kind of suits your design purposes in your network. So once you're in the OSPF configuration mode, you can then go and basically do the same commands you did on here, but for these interfaces there. So we're going to do network 10.10.9.3 area 0. Got 9.3, 12.1, and 11.3. Now, as you see, we actually got some neighbor adjacencies from our other router that's already configured as we set this one up here. And what was the other one I missed? So 11. Yeah, 11.3. All right. So connects out here. So show IP OSPF. Then you can do neighbor. So you can see we got a full neighbor adjacency with the 10.9.1 address that's sitting on this interface there, which is on router 2. So now if we go back, and you can see also here, it also formed a neighbor adjacency too. So now on PC4, if I was on PC4, I was on 3. Now let's move this over here. So if I try and ping, go back to my design here. If I try to ping 10.10.8.5, ping 10.10.8.5, we have connectivity now to that particular side of the network. Now, you're probably like, well, why do we need to keep going now? Basically, we already can get to there. Well, problem is, if this link here fails, you have no way of getting, getting to the other side. So now that we want to set this up to be able to also, well, on this router, also understand the routes that are coming from this side and also this side. Because just to give you an example, if I go config T, interface gigabit 0/1, and I do a shutdown on that. Now if I go back to router or PC3 and I try to do a ping, it's not going to be able to get that because it doesn't have that failover to then know, okay, I need to go over this link here. So let's bring that back up. Let's just do a no shutdown there. That's going to come back up. Show IP route also shows the 10.10. 3.3.3 is directly connected, loopback 0. Okay, there we go. It's like, where's my routes at? Okay, so now you can see that OSPF with the O indication is saying we can get to 10.10.8.0/24 via the 10.10.9 gigabit 0/1 interface. So to get to 10.10.8.0, it uses the gigabit 0/1 to get to this 10.9.1. And also, you also see the 10.10 network as well. So I would be able to get to this 10.10 side. Now, let's go ahead and finish up the configuration on this side. Let's do interface loopback 0, and the interface, and then we'll do IP address 1.1.1.1. And that's just because the loopback address is always in an up position unless you manually bring it down. So that's why it's good to use that versus like your the other process it uses is one of your, believe it's the highest IP address available up in an up position, I believe it is, for your router ID. Or you can set it manually in the router in the OSPF configuration mode. So if I go in here and then go router, just set this up on this side. OSPF, let's say again, and we'll go network 10.10.10.2 area 0, and then 10.10.11.2, and I don't know, I can't remember if I put anything up there, but let's not worry about up there for now, because really it's just we're trying to test connectivity to these both sides. Like I said, again, this isn't meant to be necessarily best practice. Now there are other OSPF configuration commands. So I mean, you got like your passive interface, so suppress routing updates on an interface. You got your there's a whole lot of, like, you know, as far as like particulars that might enhance the overall usability of OSPF. I'll probably do like a little video on some of these different ones, just so this one isn't too long. But you know, your different things here, like setting priorities, you know, summary addresses, are things that you can go deeper level into to kind of make your overall network design and configuration a lot smoother. So now that that's set up, let's see, summary, show IP OSPF. Okay, so this isn't coming up with any, so let's see here. Let's make sure that we have everything set correctly. So show interface brief. Oh, okay, so we're down. That's why. So it's basically not going to be able to use these interfaces because they're down. So we need to bring those up. That's why we weren't getting any adjacencies across the screen there. So interface Ethernet 1/0. Let's do a no shut there. And then what's the other one? 1/2. Okay, there we go. Then do a no shut there. Now, that's going to come up. Should see some OSPF adjacencies come across the screen. Oh, it looks like, okay, there it goes. Yeah. So now if I do a show IP OSPF summary, let me see. Oh, neighbor, sorry. So neighbor, want to see our neighbors. Okay, so now you see the neighbor IDs, priority, the address. Like I said, you got the dead timers and things like that. Those decrement. And those we can go into too. So later, like, you know, you got your hellos and like show IP, OSPF 2, start time, time elapsed, your routing process IDs, some of these other things. Like there's so many other like settings that can be altered to kind of process like different things that would require OSPF to be either be routed a different way as you add different areas and things like that. So now if we go ahead and test again, trying to ping, we'll do a continuous ping. Let me just bring this over here. So I'm going to ping 10.10.8.5 and so just have that keep going. So I'm like, hey, that should work. All right, 10 dot, okay. So now we got to just keep that going. And so basically from PC4, it's going across here, and then it's, you know, basically utilizing this link here. But if I go to router 3 and I'll shut this down, if we go back to 4, I'm going to see it drop, and then it comes back up. And that's the power of the OSPF routing or dynamic routing protocol. You could have multiple pathways to another network, and that way your end users can get that resiliency of always being highly available to the resources that they need, and vice versa. So, you know, then, you know, I can essentially bring that back up. Say there was just a network outage or down, just basically bring that back up. And that's it. Yeah. So just as a way to kind of, you know, get yourself used to using OSPF in a production network. I'll do, like I said, some different videos on some of the different ways to maybe set like the default route on all of your PCs automatically. There's settings for that, and then adjusting like the convergence time, you know, that it notices that the link's down. So there's so many other things that kind of go into play here. You know, we're not even really talking about the inside part of this network. Like you could have VPN, tunneling between the two sites, just all types of things. But that's just a real simple overview of this particular blog article here. Like I said, so, you know, going through this, I do also have some different other commands that'll kind of show you like some other stuff that I highlighted in there. So show IP protocols shows you that the networks that you're routing for, gateway, distance, last update, all those different types of things. So I kind of go into more details in the actual blog article itself that I might have kind of briefly just explained in the video here. So again, if you know, I hope you enjoyed the video. If you have any questions on any of this setup, I'll be free to, you know, share you the configuration files that I had used. If you know, are interested in even just utilizing these same configs, I'm using eveng.net. It's just a free emulation software that I installed in my home lab. So if you're using that, I can even share the config files with you as well for this particular lab. Again, thanks for tuning in. If you have any questions, leave them in the comments. Anything or any errors you might have seen in the video, let me know. I'll get that updated and hope to see you next time.